This video, I'm going to solve a few application problems for the law of sines. Um, so let's go ahead and get started with this. The first one is going to be just like what we did in the last video with the ambiguous case. It's just that we have a given triangle with a given angle of 31 degrees in the lower left-hand corner here. And the side opposite that is 9, and the side adjacent to that is 11 for our side angle. This is side B, this is side A, this is angle B, this is angle A, this is angle C, this is side C. So we need to find the missing sides and the missing angles, round everything to 2 decimal places. We also have the possibility of a second triangle over here. That would be A prime, C prime, B prime. We'll figure out in a second if we have that, but it would look kind of like that, where angle B would be the obtuse angle instead of angle C. So start by solving for angle B. That sine of angle B is going to be equal to, over side B is going to be equal to sine of given angle A over given side A, and that sine B is going to be equal to 11 sine of 31 over 9, and that B is going to be the arc sine of 11 sine of 31 degrees over 9. So arc sine of 11 sine of 31 degrees divided by 9 is about 39.01. Add 31 to that, and then 180 minus that gives us 109.99 degrees up here. We'll find side C now that we have angle C. So C is to sine 109.99, as A is to sine of A. C is 9 sine 109.99 over sine of 31. And side C is going to be about 16.42. Are we done? We're not sure. So let's go ahead and figure out if we're done by figuring out what the other angle B could be here. We took 180 minus 39.01. We would get possibility of 140.99 to go with our angle A that hasn't changed. We're going to add 31 degrees to that. And oh, we have less than 180 degrees, so there is a second triangle. 180 minus this answer is 8.01. And side A is still 9, and side B is still 11. So I only have to find C prime over sine of 8.01 is equal to 9 over sine of 31 is still given. 9 sine of 8.01 over sine of 31. and we get the C prime is about 2.43. I filled in B prime and C prime there as well, so you have everything in the pictures. Hopefully you caught the process as we went along. Now we've got a situation where there's an airplane and there's two spotters here. And we know that the spotters are given to be 3 miles apart from each other on the ground. So here's spotter 1, spotter 2. And spotter 1 sees the airplane, the 10-degree angle of inclination, spotter 2 with a 21 degree of inclination. Why this distance from spotter 2 to the point below the airplane here is unknown. Might help me to solve for that. I actually can try and solve everything so that I solve for y right away. I'm going to try and do that since I know that that's my objective. So I have that tangent of 10 degrees is equal to y over x plus 3. And I know that tangent of 21 degrees is equal to y over x. I want to keep the y's and get rid of the x's if possible. So x plus 3 is equal to y over tan 10. And so that means that x is equal to y over tan 10 minus 3. So x is equal to y minus 3 tan 10 over tan 10. If I make that substitution for x, that tan 21 is equal to y over y minus 3 tan 10 over tan 10. I don't like that complex fraction, so I'm going to make this tan 21 is equal to y tan 10 over y minus 3 tan 10. And then I get y tan 21 minus 3 tan 10 tan 21 is equal to y tan 10. So y times tan 21 minus tan 10 is equal to 3 tan 10 tan 21. And y is equal to 3 tan 10 tan 21 over tan 21 minus tan 10, which is approximately, let's type this in, 3 tan 21 times tan 10, my numerator, divided by denominator tan 21 minus tan 10. Close that up, and we get about 0.98 miles above the ground, which is good. So that's several thousand feet above above ground level. That's very normal for an airplane to be that high. They're not too close to the ground, they're not too high. So we've got, this was the two triangles that we solved for. This is 0.98 miles. And I'm going to solve this last one here in this video. Might come back and make a video with some more application problems in a little bit, but got a surveyor is standing here. We've got a building here. And we've got a tower on top of the building here, right? So I'm going to call this B for the top of the building, and I'm going to call this T for the top of the tower. And he's got sightings that he's looking at like this, and that he is 66 feet, sorry, 66 meters. I think it is, yeah, 66 meters away from the base of the building. And when he takes his first measurement to the top of the building, he finds that it's 39 degrees. When he takes the measurement to the top of the tower, it's 49 degrees, which means that there's a 10-degree difference there. And we want to find the height of the tower, the radio tower. So let's call the height of the tower T and the height of the building B. And I'm going to say that tangent of 39 degrees is equal to B over 66. Tangent of 49 degrees is equal to B plus T over 66. So just like I did last time, I'm going to make a substitution. 66 tan 39 is equal to B. So tan 49 is equal to tan 66 tan 39 plus T over 66. So 66 tan 49 is equal to 66 tan 39 plus T, which makes T equal to 66 tan 49 minus 66 tan 39. 66 tan 49 minus 66 tan 39. And we're going to round this to 2 decimal places, that the tower is approximately 22.48 meters tall. And we're going to leave it there for right now. Come back and we'll do some more applications in another video. Have a good day.